Hi all, welcome to my channel. This video we are going to talk about singleton design pattern. In the previous video I have talked about other 4 creational design patterns, and this is the last video on creational design patterns. The next video I'll talk about structural design patterns. In this video we'll learn about what is singleton and different types of singleton, and what are the Java programs for each type of singleton with an execution. Let's what exactly singleton is ensure a class has only one instance. For example, let's talk about a DB, right? When you're storing a DB, the drivers, it's basically we need to maintain as a singleton. It should be as a single instance. And also when it comes to Java programming, there are multiple ways of we are using daily singleton instance, like caching, like logging, like drivers. These all things will be considered as singletons, because their object should be constant, and throughout the application we should access those objects only. Yeah, that's basically called as singleton. There are multiple ways of dealing with singleton. There can be singletons we can design without thread safe, and there can be singletons we can design with thread safe. Because in a real world applications, right, there are n number of threads accessing our application, so we should make sure those classes which are actually singleton should create only single object. So this is basically small class diagram singleton, which has only single, which has private constructor and only single public method called get instance, that is static, which returns basically singleton class object. So basically what are the applications when managing access to resources which shared entire application, and also in real world applications, let's say when we are in PCs, right, generally we are in hostels. So across the hostel there is basically single what you call washing machine. That washing machine here we call as singleton. So all the people should wash into the same washing machine only, that's shared across the complete hostel. So similarly there is a centralized kitchen is there, that's a singleton. So this is real world examples of singleton. There are types of singletons are there. First is normal singleton, eager singleton, double locking singleton, bill push singleton, static block singleton, and enum based singleton. You can use any of these things. By default, if you're using a Spring Boot application, right, by default every object creation inside the dependence through dependence injection, which is basically singleton only. Now let's talk about in a sequence way, normal singleton, which is basically we cannot guarantee singleton is basically thread safe. Let's talk about how we return singleton. This is the singleton as we have standard Java structure with singleton class, which has a single function called get instance. So singleton called normal singleton, which is basically has an object and a single get instance. We are first checking if object is null, and we are returning the we are creating an object and we are returning the object. Let's say there is class A and class B accessing class C. So class C is basically singleton. So class A is basically accessing get instance. Now class A, initially the object is null, we are creating a normal singleton, we are returning that particular object. Next time let's say class B accessed. So now class B, when we are accessing get instance, by the time object is already created which is not null, we are simply returning the object, we are not creating the second object. So this is a normal example of singleton, right? Now you understand what exactly singleton means. There is a flaw in this way of implementation, because let's say class A and class B are accessing sequentially. That's why the object is created only once, class A and class B is getting the same object. Let's say there are 10 classes are accessing a singleton object, and all were accessing in a parallel. So by the time of object comes to 10th, right, there might be two different threads, might be chances of creating an object of two different singleton objects. It is because this is not thread safe function, right? We cannot guarantee this will become as a perfect singleton, because two objects can come to here, and two objects, first time it will check, okay, object is null, okay, and thread A comes, thread B comes, thread A checks object is null, and before accessing the 11th statement, right, thread B also checks and still object is null, and both thread A, thread B basically creating a new objects, and it will return the respective objects. It will break the our main goal of achieving a singleton. So how can we achieve a singleton is like basically with the help of basically synchronized statement. Like let's say if you put just synchronized on top of the function, right? So at a time you can only access only single thread to this complete block. So thread A, like let's say thread A, thread B came here. So thread A is check, first it will check like whether get instance is free or not. So thread A is basically checks it's free and it will acquire the lock, and thread B will not acquire the lock because thread is already acquired. It will be in waiting state till thread A till thread A release the lock. By this so by this way we can make this as a, like singleton, but this is like very costly operation of making synchronized at the functional level, because it will cause the performance performance drawback, because there are 100 threads are simultaneously accessing the synchronized block. There are 99 threads will go in a waiting state, and then it will it's like basically performance issues, like mentioning the synchronized keyword at the method level. That's why many people will not suggest of using this approach. There is another way of doing this one, is called basically doubly lock singleton, which means like here we are locking only one time, right? Why can't you lock 2 times? Let's see how we lock here. Like, so in the doubly lock singleton, why I'm mentioning the instance as volatile means because multiple threads keep on accessing this particular instance object, right? It shouldn't get like it should be visible throughout all the threads. For all the threads, it should be single instance. It should not create 100 different objects, 100 different instance with field for 100 different threads. That's why volatility will solve the visibility problem. You used to modify the value of variables by different threads. It means multiple threads can be used in a method and instance of the class at the same time without any problem. That is the main important thing. Now this is like basically here we check the normal singleton at the synchronized keyword at the functional level, right? Here first we are checking the if instance equals to null. If it is null, then we are synchronizing only this particular block. We are not synchronizing this entire block, this entire method. This way we can achieve the singleton, but this is also not guaranteed thread safe. Like when 2 threads T1 and T2 comes to create an instance and execute, if instance equals to null, both threads have identified instance variable to null. Thus assume they must create an instance. They sequentially go to synchronized block and create the instance. At the end, we have 2 instances. Here, let's say in the line number 20, right? Let's say 2 threads T1 and T2 basically saw like, okay, this instance is equals to null. So even though we mentioned synchronized at this level, right? So let's say T1 will wait and T1 will basically create here, and it will return. But by the time T2 already waiting at the 21, T2 is not waiting at 20, which means like it is only single checking only. It's like not double checking. It will not guarantee like a single thread will be single instance will be created. To overcome that one, we will use to create like two way of if condition checks. One is like at line number 30, let's say T1 and T2 came. So at that time both see issue equals to null. So it will go to 31. So 31 for sure, because of synchronized keyword, only one will be entered. So second one won't be entered. It will wait. So for T1 will see instance is still in null position, still in null state. That still is most important here. At 33, T1 is basically T1 is still sees it's a null. So it will create a double like singleton instance. It will return. So then whenever this whenever here log got released, and in the 30 here so 32 line T2 will come, T2 will check by the time 34 T1 already created an object. Now this will become an object. Now whenever T2 came, now here instance is not null. That's why because of this extra condition, it is not going into this particular block of T2. Even though there are 100 threads are simultaneously accessing, only single one can enter here. It will try to create an instance. By the time it will come out from 36 to 37, we have instance is not null. After coming 37, after coming off to the 36, then only the other thread can only access this particular block. By this way, we can make sure that this particular block will create a single thread. Doesn't matter how many number of instances are there, like how many number of threads are accessing simultaneously. So this is like basically double A lock singleton, mostly used in applications. Yeah, let's see about, like, we covered like normal singleton and double A locker singleton. Let's talk about eager singleton. Eager singleton is nothing but during compiling the programming itself, we are creating the object. We are not creating an object when we are calling the get instance. By this way, it is guaranteed that only single instance will be created, because by the time of programming ready to execute, it will already has an object in the memory, so that it will simply return the same object. This is like basically costlier operation, because sometimes construction creation might be very costlier, storing everything in the memory. That's why we generally don't prefer the eager singleton. We see drawbacks. Instance is created irrespective of it's required of in runtime or not. We are creating irrespective, but that is not very useful when because of like memory constraints. Like if this instance is not big object and you can live with the being unused, this is the best approach. If this very lightweight, just like empty constructor kind of thing, but this singleton has like 100 fields. It's like very with the single object creation itself, it is basically taking some kind of space, let's say 5 to 6% of space in our complete memory, right? Then this kind of initialization we shouldn't support. Only go to eager initialization when your creation of instance is like very lightweight, when creation of object is like very lightweight. So this is like eager. Next we go to build push singleton. So build push singleton is like similar to of eager initialization, but it's quite different. Until we need an instance, the lazy holder class will not initialize until required, and you can still use other static members of build push singleton class. Here if you see, until unless I call the get instance, this lazy holder is like lazy holder dot instance is not returning anything. Like, so the static block only executing when we are calling the get instance. Until we need an instance, the lazy holder class will not be initializing until required. So this is also very good way of designing singleton, like build push singleton. The person named Bill who found this particular way of designing the singleton. So create a lazy static class and then do the eager initialization. The main singleton will basically call whenever it's required during a runtime only. Like this is basically build push singleton. Next is like static block singleton, which we just discussed, right? Like similar to eager singleton only. During compile time itself, we are creating a singleton and we are returning the same instance. Like both, whenever your application is like too lightweighted, right? Your creation of object is not costly, then you can go with this kind of singleton, static or like eager. It's up to you. And the last is like enum based singleton. Enum based singleton is basically enum provide implicit support for thread safety. That's why we shouldn't concern about like thread safety, and only one instance is guaranteed with the help of enum. So mostly in all the gang of books, the best way of implementing a singleton, people will suggest the enum based singleton only. Like in enum based singleton, we have a single enum field called instance, and this is already, so when we can access like enum dot under driver function, we can simply access that one enum dot instance. This is basically creating the instance of enum. You see, this created the enum singleton instance class, right? So this is the way of creating an instance of enum. Like here you can access the methods. So basically people used to choose enum based singleton is the best way of doing one. But let's see how we guarantee like normal singleton versus double locker singleton. Because of two locks, right, it is guarantee of a single thing is creating, right? So I have simulated with the help of like executors. these things are not necessary, just for execution purpose I have created. Once we execute it, right, it will create like for normal thread created instance. So these are all like thread hash codes it was created. For doubly lock, these are all like thread hash codes. So it doesn't matter how many times we run. For a doubly lock for singleton, only one instance will be created. For a normal singleton, depends. It might be it might be only single instance created, or it might be more than one instance might be created. So you can check like every time running this particular function, because initially I was fixing the threads as like 100 threads, and I was starting like the worker thread. So I have created two runnables like so here if you see, right, here if you see three objects are created for if you're using normal singleton. That's why I said normal singleton is like not thread safe, like. Whereas if you see the doubly lock singleton, right, anytime it doesn't matter, only one instance will be created. That is the main difference between the doubly lock singleton and singleton, because with the help of single if condition we cannot guarantee that is thread safe. Here if you see, three different instances are created here. How I'm simulating here is like basically I'm creating two runnables. I'm implementing runnable. I'm overriding the run method, and every time I was getting the instance of first time getting the instance, I was printing the hash code. Second time, if I get the instance, right, it should return the same instance, but because of this is not thread safe, it is not returning the same instance. Other thread also accessing, because every time I was running everything in a parallelly, like because of this for loop, right, I was executing this worker in a parallelly. Execute the given command at some time in the future. The command may execute it in a new thread in a pool thread. So I have created anyway 100 threads. So that's why any one thread can pick up to do this task. After that one, I was waiting till it becomes shut down. So this is the example of how I'm shutting down. Once I shut down, I was just I was starting the other doubly lock. So double lock also I'm doing same thing. I was creating doubly lock in a runnable. I'm creating a class called doubly lock singleton and implements the runnable interface and overrides the run method. And here I was calling the doubly lock singleton. Because of I am using doubly lock singleton, it is guaranteeing that only single instance is created. If you see, no hash code is not changed at any time, even though I am creating 100 threads. But whereas a single thread, sometimes hash code is changing and sometimes hash codes are constant. Only one thread object is created, but sometimes there are like 3 objects are created. That's why people mostly prefer using doubly lock singleton. But generally, like in the among gang of design patterns everywhere, if it is like if your singleton, if your object is very lightweight, then go with the eager singleton, or like what you call like static block singleton. But among all the singletons available over here, right, the best thread safety. So by this way, I think you can create like this is the way of singleton, how singleton works like. So anyway, I was pushing all the code in description, all the code in the in my GitHub, right? So I think by this video, all my creational design patterns are completed. From next video, very soon I will start like structural design patterns and behavioral design patterns like. So if you have any doubts, right, please feel to write everything in comments. I will try to explain with my knowledge. If I did any wrong thing, then please correct me also, so that I can modify in the GitHub so that people can get the latest one. So I will do one video of quick recap of like all my five design patterns of creational design patterns very soon. So till then, please go through this all the videos and please get an idea of like design patterns like. And we'll soon meet in the next video. Till then, bye bye.